All right, everyone, welcome back. And now we are in Chapter 13, Part 3, which is all about biomass energy. And today we're going to talk about modern carbon versus fossil carbon. We're also going to discuss solid biomass, a little bit on wood, charcoal, and manure. And then lastly, we'll talk about the biofuels, ethanol, and biodiesel. And our objective is to be able to compare and contrast the various forms of biomass energy. So in a nutshell, biomass energy, like most of the other forms of energy that are on Earth, is energy from the sun. And biomass energy is going to include all of the above of wood, charcoal, manure, plant remains, municipal solid waste. And as we said, for most of those sources, the sun is the ultimate source of energy. Pretty much every kind of any energy source, really, except for uranium, is going to be a source of energy that will be from the sun. Biofuels. Biofuels are going to be liquid fuels such as ethanol and biodiesel. Okay, and we'll talk about those in a little bit. This graphic here just reiterates what I just mentioned. We've got our fossil fuels up at the top here, and fossil fuels again were formed by photosynthesis by ancient plants and algae to get all of our kinds of fossil fuels up here. In terms of renewable energy, again, the sun is the ultimate source of energy, and through each of these processes, this is how we get to our renewable forms of energy. And we'll be talking about solar, wind, hydroelectric, geothermal. We'll talk all about those in the upcoming sections. And photosynthesis by modern plants and algae, that's where our biofuels can come from, our biomass and our biofuels, wood, charcoal, manure, and our liquid biofuels. So this is what we're talking about today, everything in here. And as I said before, the nuclear energy, not from the sun, as well as tidal energy. Tidal energy is from gravitational pull from the moon, and again, we'll talk about that at a later time. Now, to discuss modern carbon versus fossil carbon, there is a lot of confusion about, for some people, about how burning biomass like wood can be better for the environment than burning something like coal. Okay, and to explain that, we have to look at the carbon that's in the biomass and then the carbon that's in the coal. And if we look at the carbon in the biomass, we can see that the carbon in the biomass was in the atmosphere and probably as carbon dioxide relatively recently. If you're talking about the geologic time, the carbon in the biomass was in the atmosphere relatively recently, and so it was taken up by a tree going through photosynthesis, and then by burning the carbon in the biomass, we're putting that carbon back into the atmosphere. Okay, so again, burning biomass is taking the carbon in the biomass and returning it to the atmosphere. That carbon was in the atmosphere relatively recently. Now contrast that to the carbon in coal, and when we burn coal, we're burning that carbon, and that carbon's been buried for millions of years, and it was out of circulation until we dug it up and then we began to use it. And so what that does is that results in a rapid increase in the concentration of CO2 in the atmosphere. If you think of it in kind of like money, if relatively recently we switched over to the new $20 bills. Okay, and so what we've got is we've got the new $20 bills in circulation, and so theoretically, it might be possible if somebody has a bunch of old 20s, a big reserve of the old $20 bills, and we start to use those, and we put those back into circulation, then we're taking all of those old bills and we're putting them back out there when they had been locked away for a very, very long time. So that's the difference between modern carbon versus fossil carbon, and that fossil carbon's been buried for a very, very long time, and modern carbon was in the atmosphere relatively recently. So by us burning it, it's just returning the carbon to the atmosphere as part of the natural cycle. Carbon neutral is another vocab term that we did talk about a little bit when we looked at our personal energy audits. And this is an activity that does not change the atmospheric CO2 concentration. And to be carbon neutral, there are some people that argue that the only way to be carbon neutral is to not use any fossil fuels whatsoever. There are also other people that argue that for every amount of CO, every action that you do, that you use fossil fuels, you need to do another activity that's going to absorb that same amount of CO2. So, for example, if I use, if I use 100 gallons of gasoline, I need to, and I emit all that CO2 into the atmosphere from that gasoline. I need to, for example, plant X number of trees that will remove that CO2 from the atmosphere that I just put back into it. So again, that's being carbon neutral. Biomass. Now, biomass is going to be solid, our solid forms, and we've got a couple of different forms: wood, charcoal, and manure. And these are used to heat homes throughout the world, a lot of the time in developing countries. And going back up to the top with net removal is removing more timber than is replaced by growth and is unsustainable. And earlier in the course we looked at different methods of deforestation, but just another term for you to know is net removal. And we also have liquid fuels, ethanol and biodiesel. Together they're biofuels, and they can be used for substitutes for gasoline and for diesel. And we're going to talk a little bit more about biofuels coming up. And then don't forget, we are going to have that afternoon where we're going to work with Mr. Peters' AP chemistry class, and we're going to be putting together and hopefully creating some biodiesel. But before we get into that, I just wanted to show you a couple of quick pictures here. This first picture in A to the left, it's a coal market in the Philippines, and again, a lot of people in developing countries rely on coal for cooking and for heating. And in picture B there, this is an area of land this is a result of that land after it was denuded for charcoal production. Okay, and so again, if you check back in your book, page 352, you can get a little bit more detail on that. This picture here shows particulate emissions, specifically in Montreal in January 2009. And these emissions were reportedly caused by the burning and the release of particulate matter due to too much use of wood stoves. So as I said, I just want to mention a little bit more on biofuels and biofuels, ethanol, and biodiesel. So ethanol alcohol, more than 90% in the U.S. comes from corn. The U.S. is the largest producer of our ethanol alcohol mixture. And there are a lot of vehicles, they're called flex fuel vehicles, that can run on gasoline or E85. Now as a drawback though, this fuel is less efficient as regular gasoline. So again, if you're talking about fuel economy, you're not going to get as many miles to the gallon, but you're going to have less pollution if you're using this ethanol alcohol mixture. The other drawback is using corn as fuel. So again, corn is one of our major crops grown in the U.S., and a lot of people think that we shouldn't be growing these crops for fuel. We should be growing them to feed people that don't have any food. So again, that is a controversial topic. Biodiesel is kind of similar. It's a mixture of 80% petroleum diesel and 20% biodiesel. And it has to do with the photosynthetic microorganisms there. And this is the stuff that we are going to be trying to make. It's theoretically possible, actually, to start with 100% or straight vegetable oil, which is SVO, which is what we're going to do, and then to turn that into to biofuel, which can run in a regular diesel engine without any kind of modification. And there is an effort at UConn. In the book talks about Dartmouth because the author of the textbook is from Dartmouth. But you know me, I'm Husky, and at UConn the buses are the Public transportation buses, sorry, they run on a biodiesel mixture, and they've got a really great program. Um, and if you click the link there in the PowerPoint, or if you just do a Google search for Yukon biodiesel, you can read up all about read up all about the efforts going on at Yukon. Here are your checkpoint questions. Number one, what are the major forms of biomass energy? Number two, why is energy from modern carbon potentially carbon neutral? Number three, why is it important to find abundant sources of biomass energy? And four, what are the advantages and disadvantages of different forms of biomass energy? So go ahead and answer these checkpoint questions. Again, you can either do that in Edmodo, that's what I would prefer, or on a separate piece of paper that you can hand in at that time. And when you finish this section, you can move on to the next one.